Good morning, everyone, and welcome to Local Law 15, Bird-Friendly Building Design. Before we start the webinar proper, a couple of housekeeping issues. Number one, we will be recording this presentation for future reference. Sorry, I beg your pardon, I'm just reading something. Secondly, we will be proceeding with a team of people, which you will shortly introduce. So complying with Local Law 15 will potentially affect the form and materials of your building, the focus being on the glazing required to achieve bird-friendly fenestration. Since compliance with the law has the aesthetic and cost implications, it's important that owners and architects appreciate the options available. Okay. So before we start again, one other thing, if you have any questions, can you put them in the Q&A session provided? We will look at those as the webinar proceeds, and we will respond either in writing or at the end. So anyway, we have several speakers to assist you in understanding this important topic. So firstly, we have Dr. Christine Sheppard of the American Bird Conservancy. We have Hoffman and Jennifer Highfield from Viracon, Nick Kurta from Wausau Window and Wall Systems, and then from CANY we have Beverlee Danser and myself, Tim Wynter-Stoner. Okay, the webinar structure. We will follow the following presentation. We'll start off with an introduction, and then we'll get Christine from the American Bird Conservancy to look at the origin of the law. Then we're going to briefly discuss the application of the law. And then Viracon will start looking at glass types and options for designers to use. Then followed by Wausau, we'll look at the impact of the law on windows, particularly things like cost and delivery times. We'll do a brief summary at the end of it all, and then we'll proceed to questions. Okay. So the benefits and opportunities availed by the law are clear to me. An article in the Guardian newspaper from a week ago described a volunteer from the Audubon Society picking up nearly 300 dead songbirds on one day from the sidewalks around the World Trade Center. So Dr. Christine Sheppard will follow this, and she will talk about the devastation caused by bird collisions from buildings, which led to this law. Now that Local Law 15 has been adopted by the Building Code on January the 10th of this year, often unjustified negative commentary has focused on the aesthetic and cost implications of the law. But our take on it is this: building laws inevitably place necessary constraints on architects and owners, dating back at least to the Triangle Shirtwaist Factory fire of 1911. So constraints are not antithetical to cost effectiveness and good design. 20th and 21st century architecture has thrived under building law. And in fact, Orson Welles went even further, and he said, the enemy of art is the absence of limitations. So we believe here at CANY that understanding and addressing bird-friendly design at the start of the design process, rather than as an afterthought, will lead to aesthetic and cost benefits to your projects. So now we're going to look at the origin of the law, and I'll hand the presentation over to Dr. Christine Sheppard from the American Bird Conservancy.
Can you all hear me? I'm sorry, I thought I had disappeared for a minute. I'm Chris Sheppard from American Bird Conservancy, and you won't be surprised to hear that the story I'm going to tell you starts with birds. I know that normally in your professional lives, when you encounter birds, it's usually pigeons or starlings or house sparrows, or maybe occasionally Canada geese and gulls. But the kind of bird that we're talking about now is songbirds, warblers, thrushes, sparrows, what I refer to as real birds, not nuisance birds. And before I go very far, I want to show this picture. Bird-friendly design is not incompatible with designing glass boxes if that is what you need. I just want to make sure you know that this is not what I'm, expecting or wanting you to design exclusively. So why do we care about birds? Obviously, birds have value in themselves. They have tremendous economic value that in general we don't know about. When California burns to the ground, birds will bring seeds back in so that plants can regenerate. Birds make a tremendous contribution to agriculture. They of insects that can destroy crops, that can destroy trees, that can give you things like West Nile virus. So birds are much more important to us than we normally recognize. We started to notice collisions at the end of the 19th century when lighthouses began to be electrified. And there were a number of events somewhat similar to the one at the World Trade Center, usually associated with bad weather, where large numbers of birds would be found dead in the morning. And so people started to try to figure out what was causing that. Since then, we've learned a lot, and one of the things that we've discovered is the magnitude of the problem. People have started to document the collisions in their cities. This probably started in Toronto and Chicago, where they had a lot of mortality events. The Smithsonian did a meta-analysis published in 2014 that showed that as many as 1 billion birds are killed every year in the US alone, colliding with glass. This is clearly contributing to the decline of our songbirds, and our songbirds are in decline in general. The only thing that's really worse is cats. Please keep your cats indoors. It's better for the cat. It's definitely better for wildlife, and it's actually better for you too. The majority of birds that are killed colliding with glass are songbirds, but almost any kind of bird you can think of has and will collide with glass at some point. Our songbirds, most of them migrate twice a year between their breeding grounds in the north and their wintering grounds in the south. So twice they run the gauntlet of all the built environment between the northern part of North America and the lower part of North America. They migrate at night because then you don't have the sun beating on your back, the winds tend to be lower, there are fewer predators, but also because you have to stop periodically to feed. And you're feeding during the day, and that is when collisions take place. So these sort of old associations of nighttime and collisions in tall buildings turn out not to really be what the collision problem is all about. Birds have to feed. When they've come down after a stage, they look around for greenery. And most collisions take place in that zone where birds are active, just the way most car crashes happen within 20 miles of home, because that's where you do all your driving. Most collisions take place in the areas where birds are active. It doesn't mean that there are no collisions higher up, but the majority of collisions take place in glass near greenery and on glass that reflects greenery. This means that almost half collisions take place on, which is something we don't tend to think about. This is a hard problem to get a handle on because it turns out it happens everywhere. It's not just collision events in a dark area with a bright light like a lighthouse, or back in the 30s like the Washington Monument. There's so much light pollution now. Birds are attracted to light, which means that they are sucked into the built environment. And then as the sun comes up, they start to collide with buildings. So most of the birds that died at the World Trade Center didn't hit those buildings at night. They hit the buildings right around dawn. Most of the rest of collisions, almost another 50%, take place on low-rise buildings. Now, this doesn't mean that there are no collisions on high-rises. It means that the majority of collisions on high-rises take place on the lower floors. There is some incremental mortality with high-rises, but most mortality happens in the lower 17-odd floors. why does this happen? People often wonder, what is it that birds, they run into glass and we don't? People don't see glass either. We learn about glass when we're very young. We probably don't remember the first couple times we bumped into something. But people are injured running into glass walls and windows all the time. Birds never learn the concept. Their brains can't understand the idea of a transparent barrier that could also be a mirror. That's something that we learn. And if I take away the cues that you learn, you're not going to be able to tell me if this is a tree reflected in mirrored glass, or if this is a tree seen through a window. When I show you this, you know that right angles are not natural. You see that crack there, so you know it's got to be glass. It takes this much to know that that's a reflection. Birds don't understand any of those cues. They take what they see literally, and they're just as apt to fly to a reflected habitat as they are to a real one. Now, it helps to know a little bit more about birds. And I promise you this is not a biology lesson, but there are differences between the way we experience the world. We're primates. Our eyes are close together in sort of flat faces. We don't have anything sticking out between our eyes. We see more or less the same thing with each eye, which gives us good depth perception, 3D vision. It also tends to make us think of the world as something that we're walking into. Watch where you're going. Birds, on the other hand, have eyes on the opposite sides of their heads. So imagine, or try to imagine, seeing different things with each eye. And I do recommend Spies in Disguise. If you haven't seen it, they come closest to actually understanding how birds see the world. Birds use different methods to figure out how fast they're going, when they're going to get where they're going. They have limited 3D vision, primarily so that they can decide if what they've picked up is something they want to eat or put in their nest or something like that. What's out to the side and behind them is as important as what's ahead of them. They presumably experience the world as something that they are in the middle of, and where they're going is not necessarily the most important thing, especially if they believe they're flying through open habitat. So my model of a bird in flight is actually a kid texting on a skateboard, but I've never been fast enough to get one on video. So this guy's going to have to do. His attention is definitely not where he's going. Obviously, he's not looking to the side or behind either. But if there were an unexpected obstacle, he would probably run right into it. And this is what I mean about a cluttered versus uncluttered environment. So in an open environment, birds believe that they are flying in a safe area. And to stop collisions, what we need to do is call their attention to what's in front of them and make them believe that it's a cluttered environment that they don't want to fly through, that they would be better off flying around. So this is the photograph about the literal reflections. Each of these trees is as likely a destination for bird as the real tree out here. And you can easily imagine people bouncing off that glass too, or all those people in the Apple building in Cupertino. So this is the part where I have to tell you that some of this is actually my fault. I used to be the curator of birds at the Bronx Zoo, and designers were always trying to put transparent handrails or mirrors into exhibits or into the space outside, threatening either our collection or the birds that lived on the grounds. Because of this, I became actively involved in the collisions activity work. I discovered that this gizmo, which we call a tunnel, had been invented in Austria in response primarily to birds colliding with transparent highway noise barriers. So that obviously made sense since I was interested in transparent barriers too. The American Zoo Association gave us a grant to build this. Around that time, I started working with a group of architects trying to create a point in the LEED system, an innovation credit for reducing bird collisions. And at that point, around 2009, 2010, the best advice that we had for architects sort of went, increase visual noise on the facades of your buildings. Don't use large expanses of glass. Weren't quantified, that were almost impossible to know whether you complied with. And as we were realizing this, that we had to provide objective ways of looking at different types of glass and how well they could deter collisions, we created Pilot Credit 55. So if you're familiar with that, it uses this threat factor rating, which is the result of testing in this tunnel. The tunnel is based at a bird banding station. The birds are put into this end of the gadget. It's very dark in there. They see what appears to be two different ways to get out when we're testing glass on one side and clear glass on the other. And you'll also notice here that there's a net. The net keeps birds from actually impacting the glass. Every bird gets one flight through the tunnel. We open this door, we let them out. The score is based on the percentage of birds that fly towards whatever we're testing. So the fewer birds fly towards the test glass, the lower the threat factor, the better we are. Now, at this point, we had really begun to understand the problem. And it's a little ironic that an incident like the one at the World Trade Center last week attracts so much attention, because on a normal day, dozens of birds are found dead in the very same area. The total mortality on those buildings is much higher than the few hundred birds that last Tuesday. But that doesn't get in the news. Virtually any piece of glass in any environment can be a hazard for a bird, which I know is not what anybody really wants to know, but it's the truth. So we started investigating legislation as a way to get this information out. I probably naively thought early on that if we knew how to solve the problem, people would just go ahead and do it. That's obviously not what happens. But one of the best ways to reach an awful lot of people, especially a lot of professionals around architecture, is to pass legislation. And in 2011, we helped San Francisco pass the first bird-friendly design law, their standards for bird-safe buildings. Now, what I think is really telling is that in the subsequent 10 years, more than a dozen other communities in California have passed legislation, often slightly more stringent legislation. And what this says to me is that they're looking at San Francisco and they're seeing that they don't have to build ugly buildings. It's not costing an arm and a leg. They haven't had to hire a lot of new staff to implement the legislation. And in fact, the people in the planning department in San Francisco say that it really has not been an issue. So since 2011, in addition to in California, Minnesota has a national level law. A lot of other jurisdictions around the country have passed or are considering legislation. There is legislation that covers the entirety of Canada. The slide doesn't really encompass every single thing that's going out there. One of the things that we're trying to focus on right now is trying to increase the similarity amongst the different types of legislation. I know it doesn't help us, it doesn't help you, if every jurisdiction has a slightly different version of a similar law. So we've been trying to create some standard language in the hopes that we can start to get this more widely adopted. So as far as local law 15 goes, I certainly had never planned to paint a target on my back, but New York City's planning group decided that they wanted to do this. New York City has been implementing legislation for things like green roofs and other aspects of sustainable design for the last 5 or 6 years. And so the idea of making buildings bird friendly really made sense to them as the next step in this process. And because they used the whole idea of threat factor in this legislation, it meant that American Bird Conservancy was very involved in this, whether voluntarily or not. On our website, if you go to this link, you can find materials like the product spreadsheet and our prescriptive standard, and there are as well talking about definitions of bird-friendly materials and ideas about bird-friendly design. We also have a gallery where we have photographs of buildings that exemplify different aspects of bird-friendly design. And that's all I have today. So thank you for listening to me, and I'm going to stop sharing and turn this over to Jennifer.
Well, thank you, Chris, for that presentation. Now we're going to look at the application of the law, and Beverlee Danser will share a few comments.
Right. The predominant area affected by Local Law 15 is the first 75 feet of exterior wall envelope above grade, which should be constructed of bird-friendly material. Bird-friendly material is defined as a material or assembly that has or has been treated to have a maximum threat factor of 25. Within the 75 feet zone, a few exceptions applies. 10 square feet of a 10 feet by 10 feet area can be constructed with non-bird friendly material. However, the area is not cumulative. Where ground floor transparency is required, a maximum threat factor is 27 in lieu of 25 shall be provided. In area where flood resistant glazing is proposed and ground floor transparency is required by the New York City zoning resolution, a maximum threat factor of 36 shall be provided. The law also addressed fly-through condition. Fly-through condition occurs when one or more panel of glass that provide a clear line of sight through such element, creating the illusion of a void leading to the other side. Fly-through condition exists in the following two circumstances. When a distance between parallel glass is 17 feet or less and within 12 feet from a corner where there is a convergence of two glass sides creating a perpendicular, acute, or obtuse corner. The requirement of the fly-through conditions are more stringent than the exterior wall envelope. When such conditions are created, the exception applicable to the 75 feet zone, such as the 10 square feet allowance, are no longer applicable. Structures adjacent to the facade that create a fly-through condition by juxtaposition are also governed by the stringent bird-friendly material requirement. For example, if a glass bus shelter is adjacent to the facade, thus creating a fly-through condition, it should be constructed using bird-friendly material. A few additional conditions are affected by the law regardless of height, such as the green roof system or bird hazard insulation. New exterior wall envelope and associated openings adjacent to a green roof system on the same building shall be constructed with bird-friendly material up to 12 feet above the walking surface. Bird hazard insulations are defined as monolithic glazing insulation that provide a clear line of sight on the exterior of the building, including but not limited to glass awning, glass handrails and guards, glass windbreak panels, or glass acoustic barriers. Finally, any see-through element of the facade that protrude more than 10 inches from the face of the exterior wall envelope are required to be constructed of bird-friendly material regardless of height. When it comes to existing building, the law is applicable only when all glazing is being replaced. The law does not apply to alteration that do not replace all of the exterior glazing of the building, storefront replacement of a portion of the exterior glazing within the building.
Thank you, Beverlee. And now we're going to turn the platform over to Ryan and Jennifer from Viracon to talk about available glass types.
Hello, everyone. My name is Jennifer, and I've been with Viracon for 8 years in the architectural design role. I primarily assist architects as they select glass for buildings, and I help provide design solutions to fit both the aesthetic and the performance criteria for the project. And this, we all know, is oftentimes a balancing act, and I'm here to help with the options and make this process easier. So I'll be discussing how Viracon and glass fit into the bird-friendly application of buildings. And just a little background, Viracon is a glass fabricator. We receive the raw float glass in from various domestic float glass suppliers and then add value to the glass with all of our other processes completed in-house. This starts with cutting, heat treating, printing on glass, coating the glass, and then finally fabricating the insulating and laminated units. And with this said, today's focus will be specifically on bird-friendly products that Viracon offers. Next slide. The local law 15 of New York addresses bird-friendly facade materials and requires the material or assembly has or has been treated to have a maximum threat factor of 25. Next slide. As a glass fabricator, Viracon has been actively involved in the ongoing research to understand various glass products' potential to reduce bird strikes. To date, our focus has been on finding practical solutions using conventional glass products with applied patterns. Viracon's printed insulating glass units were tested during the fall of 2010 and 2017 bird migration utilizing the tunnel that Christine talked about, designed by ABC. And this was based on the prior test performed in Austria. The testing was performed at Powder Mill Avian Research Center, or PARC, in Pennsylvania. PARC is part of Carnegie Museum of Natural History's Biological Research Station, Powder Mill Nature Reserve. PARC has an extensive bird banding program, conducts bioacoustical research, and evaluates avian perception of glass using the tunnel test designed by ABC. Next slide. The Viracon patterns tested in 2010 and 2017 were incorporated into 1-inch insulated units. The outboard glass ply was a 1/4-inch clear glass with a ceramic enamel, frit or ink pattern on the second surface, and then Viracon's VE2M low-E coating applied over the pattern on clear glass with a 1/2-inch airspace and a 1/4-inch clear glass inboard. Next slide. Scores from the ABC tunnel test are utilized by ABC and the USGBC to assign a threat factor for each tested material. A lower threat factor means that the product deterred more birds in the tunnel test than a product with a higher threat factor. Next slide. The bird-friendly glass designs developed by Viracon have a screen printing pattern applied to the glass. The difference between them is the pattern and the color. Research indicates that patterns and colors help to restrain the collision regardless of whether the glass is insulated or laminated. Here are 3 of the Viracon printed products tested with ABC in the tunnel test. These are all silkscreen printed patterns, and colors used range from dark gray, medium gray to white. Note the threat factor 41 on the right. This option is too high to meet the local law 15. However, I just wanted to include it to show you since it's one that we have had tested. Next slide. Oh, actually go back one. Perfect. Looks like this is not showing the patterns. We have 3 more additional patterns and colors that were tested with ABC. This includes 2 line patterns that are digitally printed with alternating white and translucent frit. The glass with the best performance was the dark gray, 1/8-inch lines alternating with 1/2-inch spaces. In the test, this pattern and color combination deterred 94% of the birds, which equates to the threat factor 6. The other combinations dissuaded between 59% and 90% of birds. Though this means that all patterns and colors combinations are more effective than non-printed glass. The takeaway from this testing is that lines do tend to perform better than dots, and more contrast tends to perform better than a tight, more dense pattern. Next slide. The 2x4 rule represents the minimum opening that most migratory birds perceive as passageways, thus preventing them from trying to fly through the glass. While using the 2x4 rule can deter collisions, after additional monitoring, it became evident that reducing the space to 2 inches in both directions may protect small songbirds that will fly through a 4-inch gap. Although the 2x2 spacing is the preferred choice, 2x4 spacing has been demonstrated to reduce collisions significantly and can still receive a bird-friendly rating. Next slide. And because it's not possible to test all screen patterns and color combinations, ABC has developed a guide to selecting a template called the prescriptive path to determining threat factor. If this criterion is followed, a bird is more likely to see the pattern and adjust its flight path away from the glass. The main difference between these two prescriptive paths is the 2x2 spacing versus the 2x4 spacing. Both of these options will comply with the local law 15. However, the closer 2x2 spacing will achieve a lower threat factor than the slightly larger spacing of 2x4. Other items to include in the glass makeup are clear or low iron glass. Tinted glasses such as grays and blues will not allow enough contrast with the printed patterns for the birds to see. The frit should be an opaque frit, and also the frit needs to be applied to the number 1 or number 2 surface to comply. Next slide. Viracon is one of many bird-friendly glass options, and our range of threat factors fall between 6 and up to 41, depending on the pattern and color used. Here you can see other products such as number 1 surface films, UV pattern coatings, to honeycomb, polycarb within an IGU. Next slide. Here are 2 of the more minimal dot pattern options. These are 1/4 inch dot sizes with just over 1% coverage that follow the 2x2 spacing rule. We're really seeing that architects are preferring these more minimal coverage patterns to meet the bird-friendly codes. Here are 2 examples of common bird-friendly 1/8 inch thick line patterns with 4-inch vertical spacing or 2-inch horizontal spacing, and range from 3% to 6% coverage and are within the 2x4 rule. In order to achieve a material threat factor and or the 2x4 rule, Viracon offers options to print on the glass. Oh, next slide. Hi, you can move it to the next slide. Thank you. Viracon offers options to print on the glass done through 2 processes, silkscreen or digital print. Next slide. The silk screening process is very similar to screening a t-shirt. The large mesh screen is lowered above the glass and paint is squeegeed through the screen and applied to the glass. Then the fritted glass goes through the tempering furnace to become permanent to the glass. Next slide. A few of Viracon's standard silkscreen patterns and colors, which allow a range of coverage and colors. We have many standard patterns going from 10% coverage up to 60% coverage, and many in between. And also we can create custom colors along with our standard, about 15 or so standard gray and blue colors. Another way to print glass is the digital printer. This process is highly customizable and has multicolor options all on a single piece of glass. Next slide. An electronic file with the design is converted through specialized software and sent to a digital printer. The printer applies ceramic ink directly to the glass, which then goes through the same tempering furnace as silkscreen glass to bond the ink to the glass. Next slide. Buyer can apply the frit, either silkscreen or digital print, to the number 2 surface along with the lowy coating. This will provide the best solar performance, specifically the solar heat gain coefficient, which is much improved over applying the frit to the number 3 surface. So for solar performance and bird safe glass, the number 2 surface is the best option, as you can see with this performance data. Next slide. The SPRINGBROOK Nature Center wanted a pattern that would protect the birds and allow visitors to enjoy the view to the building exterior. They selected a medium gray vertical line pattern with 1/8-inch wide lines, 4 inches on center at 3% coverage. And this project was assigned a threat factor of 10, which is very good. Next slide. Here's the silkscreen pattern details showing the 1/8-inch lines and the 4-inch on center spacing, which follows the 2x4 rule to help deter the birds. This is a minimal coverage at only the 3.125% coverage, which will be very minor in obstructing views and is still very pleasing to the eye. Next slide. This is another example of a project that used bird-friendly glazing. This is located in New York City and is essentially clad in all glass. The Jacob Javits Convention Center is a retrofit design which used a gray dot pattern forming lines. The original building was built in the 1980s, and one of the goals to retrofit was to reduce bird collisions, which was achieved. With the new fritted glass, reduce the bird collisions by over 90%, and this is with the frit on the number 2 surface inside of the outboard glass ply. This building does have fly-through conditions, which requires bird-friendly glazing to help deter the birds from flying towards. You will notice that from this photograph taken from further back, this smaller dot pattern is not really discernible. Next slide. The Jacob Javits Convention Center was assigned a threat factor of 25. Here you can see the silkscreen is more noticeable when viewing very close up to the glass. However, when standing back, it's not obtrusive to the eye as the smaller scale dots lend themselves to be a more subtle overall pattern. Here's a close-up of the silkscreen pattern used on this project. This is at 38% coverage, and much more dense coverage than is required to meet bird friendly. This project, being essentially a glass box, is also gaining additional performance from the silkscreen and helping to reduce glare within the space. This helps lower the visible light transmittance and also the solar heat gain, which improves occupant comfort and saves on energy costs for the building. Next slide. Now I will quickly mention design elements to avoid when planning our next bird-friendly project. Highly transparent products without printing on the glass should be avoided, as the birds cannot differentiate this from sky and will not deter them from flying towards. Next, the requirement is to keep exterior reflectivity at or below 15%. So keep this in mind when selecting your low-E coatings. Viracon has 2 great options, the E2M and our triple silver, the VNE-63, which fall within this category. And this will improve the overall performance of the glass while keeping the exterior reflectance low as to not reflect too much of the surroundings and allow birds to change direction and avoid impact. Next slide. So today we have covered Viracon's product offerings that will meet the threat factor 25 or better to comply with the local law 15. Select your pattern type, whether it be lines, dots, or a custom shape such as a square dot, and then choose your amount of coverage range from the very minimal amount of 1% up to 40%. Any opaque color can be used to satisfy the design, from standard grays, whites to custom colors. It's important to remember the printing on glass will comply with local law 15 and improve the overall energy performance, occupancy comfort of the building, all while still maintaining views to the exterior. So feel free to reach out to myself or the architectural design team for assistance with your next bird-friendly project. Thanks everyone for attending today. Next slide. And that concludes my presentation. Thank you.
Thank you very much, Jennifer, for that presentation. Now we're going to offer the floor to Nick Kurta from Wausau Window and Wall Systems, where we talk about the impact of the law on windows.
Hi, my name is Nick Kurta. I'm architectural engineer for Wausau Window and Wall Systems for the great New York City area, New Jersey, Connecticut, and Northeast. My job to work with architects, consultants, and provide support and experience to select appropriate fenestration solution during the design stages of the project. Next slide. So everybody already mentioned the major points for local law 15. It's a maximum thread factor of 25 for the glass, 75 feet above the grade, up to 75 feet above the grade. All fenestration is supposed to be bird friendly, and some exceptions that smaller than 10 feet are excluded. Next slide. So how does that impact window design, sourcing, and timeline and pricing? So when we selecting glass, we keep in mind how it will impact the aesthetics, functionality of the window, storefront, and curtain wall, and on the overall design of the building. So window sizes, acoustical performance, energy efficiency, most critical factors in selecting window system for particular design. Cost and timelines, they also major factors for the selecting window and glass for particular building. Next slide. So here are a few different ways bird friendly usually made. So UV strip coating, actually the most common as of right now bird friendly would be ceramic coating or silicone frieze. Then we would have UV patterns. Also acid etching is also really popular. And they all applied on the different surfaces of the glass. Depends on the manufacturer, depends on the IGU. Each of those, they have advantages and trade-offs for effectiveness, aesthetics, but there are also other considerations such as how it will work with other glass coatings, lamination, tempering, durability, installation. So all those options for bird friendly glass, they all will affect appearance of the building from outside and view from inside, would have different price points. They will in some ways may even impact energy efficiency coatings on the glass, and may affect the glass warranties. Depends also on the glass manufacturer. Next slide. So when we select glass for a particular project, there are other important factors that we consider. I would say by now, before the transparent glass, that would be most important. So it's energy performance, visual light transmission, acoustic requirements, and sizes. All those will affect also price and how that window will and energy perform. Why I'm keeping those right now, I'm bringing those right now, because when we select the glass, we need to consider all of the options because they all interfere with each other in a way. So we would need to kind of, sometimes one option would not be available with another option, and vice versa. Next slide. So for example, energy performance and visual light transmissions. So with the most common option of a ceramic and silicone frieze, they will reduce visible light transmission. to the inside, and they are highly visible to humans, but also visible for the birds. UV patterns are less obstructive to the view than frids, but slightly less effective at deterring bird collision. Acid etching is more durable and may be combined with low E coating on the same surface. So with if you would consider the most common low E coating on the surface 2, and look into two samples on the screen. So one is for UV coating, which presented as a coating on a laminated light. So the coating is actually between the two glass, and it's basically laminated coating. With the acid etch, it's usually on a surface number 1. The same can happen with a frid. It also can be on a surface number 1. But with a Viracon, it's available also on number 2. So here's the challenges that it can present. Sometimes low E coating will not be available on a surface 2 with a particular glass combination and bird-friendly coating. Some of the options can be available on the same surface, like with Viracon. Their pattern could be available on the same surface too, as a low E coating. Why are we talking about this? Because if, let's say, we cannot make it on the surface 2, we would move it on the surface 3 for the low E coating, and it will reduce energy performance of that glass. Next slide. The same can be said about acoustic requirements. So for the acoustic requirements, we consider different IGU makeups, and it could be the standard with the same thickness of the glass and go to different thickness of the glass or combination laminated and tempered glass. What that can affect, again, with the different manufacturers, they can offer their bird-friendly coating only on certain thickness of the glass, and they cannot offer with the other thickness. So with acoustic requirements, usually you have a combination of the IGU that will provide you with a specific OITC that would be supported by test reports. And if that cannot be achieved, we need to play around and see what is available and if we can reach to the required OITC. Next slide. With the sizes, so size limitation would vary from each manufacturer and would also be dependent on a pattern specifics. Each type of coating may also have the different limitations, size limitations. UV option, the one that I presented before on a picture with the laminated option, that will basically increase the glass weight and will limit size for the operable window. That's actually just, I had a situation in a project recently where as any project in New York City, they usually go oversized and everybody would like to have a full height window and huge vents. And they selected glasses that actually has a UV coating, which is in between the glass. And that glass is available only in 1 and 5/16" IG, which is laminated combination. It's really heavy. So now we have a challenge to actually offer the sizes for the ones that they requesting. And we need to basically, in the bidding stage, we need to come up with a solution how we can make it. Next slide. So when we consider window design, we need to consider all performance requirements, not just one is a energy requirement or let's say bird safety requirement. Sourcing always have few options. With the time limit pricing, I would really expect extended lead time and of course additional cost with the bird friendly glass. So with the collaboration with experienced fenestration manufacturer can add value and save you time and expense and present many available options for the beginning of the design stage. We usually work closely with building owners, consultants, architects to select fenestration and other glass elements that will fit budget and project for the project, and while meeting the design vision and applicable building and energy code requirements. As a window manufacturer, we work broadly with different glass suppliers that can offer different options, and based on that, we usually try to select the best one that will suit the particular project. Next slide. I guess that would be, thank you. I guess we will move to the questions now.
Well, thank you very much for all the presenters for providing such interesting presentations. We hope you've enjoyed this webinar, and please contact CANY if you need any help with your bird-friendly design in your new projects. Right now we have no questions, so I think we're going to call it there. Thank you very much again for attending, and we'll look forward to having you all again some future time. Thank you.